Hello, everyone. I'm Lisa Johnson, CEO of BioForward, and from myself, the BioForward team, and our board of directors, welcome to the 2019 Wisconsin BioHealth Summit. You know, I know it's disappointing. I didn't start with pink. Some of you are new. Some of you are old. Okay, I always like to play pink, either beginning or the ending. But this year, I'm going nostalgic. Okay, did you guys see the Ken Burns special on PBS on country music history? It was phenomenal. And I am not a country music fan. But these artists were so creative and risk takers. So here they were, they overcame obstacles of drug, alcohol addiction, women songwriters being controlled by their production companies, and controlled by men. Merle Haggard was in San Quentin when Johnny Cash played there, and it changed his life. Again, he went on to become one of the most famous country music artists ever. Johnny Cash, we know that story, we've seen the movie, certainly dealt with drug addiction and overcame that. And it was really cool. He had a show, and the network was always telling him he couldn't have certain people on, whether it was women, individuals of color, songs he couldn't play, lyrics he couldn't have, and he said, no, I'm doing it. Dolly Parton, Loretta Lynn, those stories of, again, being controlled, or Loretta Lynn being told she couldn't sing certain lyrics, they broke down those obstacles. They weren't comfortable. They said, enough of that. We're doing it on our own. And again, we know that Dolly Parton is one of the best businesswomen ever. So I tell this story, and I play the opening song, because there ain't no mountain high enough on what we can achieve together. It is being creative, risk-taking, and taking control of this industry and how we need to promote it so we can continue to grow, attract talent, investments, and partnerships. See if we get it to work. So talent. We heard loud and clear from our member companies, we need to invest in attracting talent. This summer, we worked with Digital Ring of Madison, an awesome company, to launch our Phase 1 talent campaign. It was a social media campaign directed outside of Wisconsin. You guys may not have seen this. You may not have seen our landing page. We went primarily East Coast, Midwest, again, outside of Wisconsin, to advertise the diversity of our industry and also potential job openings. We had 17 million interested and qualified views, as well as a lot of other data. But we know we need to do more. Let's not stop. Let's continue to invest. That was a short-term campaign, only 3 months. That's very short. We know we need to do more. So to do that, we know we need to be more specific with some companies. So in October, with Phase 2, we're testing 3 companies utilizing animation videos created by Cat Cow Animation, another Wisconsin company. And you will see those 3 today. And this morning, we're starting with Shine Medical's story.
There was a time in history when many people thought nuclear was a dark, threatening, scary word. And rightly so. The world's superpowers were locked in a nuclear standoff with bombs that could have killed billions. But at Shine today, we're redefining what nuclear is. It all starts at our facility in Wisconsin, where we'll use a new generation of nuclear technology to help turn those bombs into medicine. First, the U.S. government takes former weapons and makes the uranium safe for us to use. Then, we use it to make vital medical isotopes, such as molybdenum-99, a medical ingredient that illuminates heart disease, cancer, and other conditions, improving their detection and diagnosis. We're also developing innovative ways to make life-saving therapeutic isotopes that can kill cancer cells with minimal damage to the rest of the body, potentially saving millions of lives. At Shine, we're driven by our passion for making the world a better place. Join us on this exciting journey as we turn the darkness of Cold War weapons into a light that improves the lives of people and the planet. Find out more at shinemed.com.
Isn't that awesome? What a great story. That's in Janesville, Wisconsin, and that started here at the University of Wisconsin-Madison. That technology came out of here. We should all be very proud today that that company is in Wisconsin and it's going to make a difference in our lives in the coming years. So, North Star also, it is just an incredible story. So, off script, but I'll come back now. We also need to have STEM talent in the future. BioForward knows it also needs to support those entities that are making a difference in younger people's lives. We have donated to BTCI Youth Apprenticeship Program, and please, companies, be looking at them. Those are great high school students to get in early to your companies for a couple years with their Youth Apprenticeship Program. Engaging Girls in STEM out of the Medical College of Wisconsin. At our annual member meeting this year, we invested in the Mortgage Rural Summer Science Camp. It was a blast seeing these kids come from these rural districts. Some of these districts have 100 kids in the entire school district. They have no opportunities to have this kinds of hands-on experience that Mortgage is giving them, and people are donating their time to get these kids excited about science, and I got to hear those stories. So again, another entity and another program that we should all be really proud about. And now this year from this summit, we are donating to two great STEM education-focused entities. MADAM, which I know some of you are familiar with in Madison. They also have an office and starting their programs in Milwaukee. And this provides girls and youth of color, grades 6 through 12, with skill-based training for technology. And then the Milwaukee School of Engineering, MSOE, provides their program STEM to Site, bringing STEM education to Southeast Wisconsin school districts. And in honor of our speakers today, and related to some of our sessions, and you'll be hearing those today, we'll be donating to the Children's Hospital of Wisconsin, the Wisconsin Alzheimer's Institute, and the Hunger Task Force in Milwaukee. And that is also just a really cool organization, bringing fresh food, nutritional food to families that just don't have those opportunities. So 3 great organizations that we're very proud to donate to. So we can make these investments and have the ability to promote our industry because we have committed sponsors and members to this organization, which also allows us to put on this summit each year. An event that brings all of you together to learn from one another, be inspired by one another, be inspired by our speakers, and to potentially collaborate. So I want to thank all of our sponsors today. It does mean a lot to us, and it really does allow us to put this on in all of our programs throughout the year. So, because of our sponsors last year, we were able to bring Chris Mason from Cornell, and a Racine, Wisconsin native. He grew up in Wisconsin, who is most famous for analyzing the DNA of Mark and Kelly, Mark and Scott Kelly, I'll get it right yet. Mark and Scott Kelly, who are the astronauts, and analyzing their DNA. He was in the news just a few months ago. So he was our keynote presenter last year, and he wants to say hello this year. There were 200 of us last year, if you weren't here, that had our phones swabbed, and some crazy bacteria readings showed up. Mine was one of the crazy ones. They got a big kick out of mine because I had my dog lick my phone, and so I had huge spikes in dog bacteria or whatever they carry. I also put my phone down by Lake Kiganza just to see if I pick up any of that blue-green algae. So I do know I had a lot of unknown bacteria, but when he talks, I am not the 97% one that he's going to reference. I just want to put that out there. So Madison became part of the MetaSub Stuck on You project that is mapping the urban biome. And that's how does our local bacteria affect our health as well as affect the health of the city. And they're trying to see, is it different in different locations? And so it's a really great mapping project. And maybe in a few years we can get Chris back and say, okay, tell us the data after all these years. What's it looking like? What have you learned? So here is Chris, funny as always, and his daughter has joined him on this home video that he sent to us.
Hello, Wisconsin. Greetings to Madison. This is Chris Mason from UW-Madison calling you from New York City. And I want to just give everyone an update on what we found last year. We collected almost 200 samples from everyone's phones there, sequenced them, and we found into a database that we can compare them to about 10,000 different viruses, about 3,000 different species. And we also found one person who was 97% unknown DNA, which is pretty mysterious and interesting. So this has led to a lot of additional work being sampled by people in the lab, as well as sampling by, you can see, this is my daughter, who, Maddie, say hi. She partly inspired the project by licking a subway pole when she was 3 years old, and turned out mostly okay, as you can tell. And we're just here in New York City, continuing to analyze the data to look for new interesting things we found from everyone's phones. And I want to wish everyone a happy Halloween, which is coming soon, as well as enjoy the conference. We've got our wreath up there, you can see, with some spiders and getting ready for the holidays. Enjoy the meeting. Please think about what's on your phone because it has traces of human, bacterial, viral, as well as other plant and animal DNA that we're keeping an eye on. And happy Halloween.
He was so entertaining last year. I seriously, I had a heart attack. I keep trying to remember. It was either 200, 240 slides, and he was putting his presentation together right before he goes out. And I'm just sweating. I'm like, are you kidding me? You can't talk that long. He says, Lisa, I've done this before, okay? Just calm down. So, yeah, that was a little distressing to me last year. So thank you, Beth and Karley, for not doing that to me this year. Speaking of them, you are in a really a great treat to hear these two women, these two very creative, intelligent, dynamic women discussing the advances in imaging and the use of artificial intelligence. Then we have a networking break, and we're going to go to panels. We have, in the morning, just technology and business tracks. In the afternoon, we'll add a professional development track. All technology tracks are in the Overture Center. Business will be in Promenade, and professional development will be in the Wisconsin room. This morning, after the networking break, we're going to have the brain health panel in here. And then in the Promenade, you'll be hearing from some Wisconsin companies. And these are going to be young companies that you may not have heard of before. And then they're going to come together in a discussion with Andrew DeMarco. So I think either one, two great sessions, always hard to choose from when we offer multiple panels and upcoming fireside chats. Then at lunch, we have our Wisconsin BioHealth Awards. We'll have lunch from noon to about 12:40. Then we'll start the awards presentation. I do have to say this is one of my favorite parts to honor these individuals. I'm, again, always inspired by them and what they have achieved this year. Two great individuals, Laura Johnson-Douglas and Rock Mackey, will be receiving the awards. At 1:30, we start our fireside chats. Again, technology, business, and professional development. I'll move to that. And again, good luck trying to choose. These are going to be really interesting sessions. Really proud of these fireside chats. You know, after lunch, you're kind of sluggish. So we were like, let's not do hour-long panels. Let's go with something a little quicker with fireside chats. So a little more dynamic exchanges. Then we'll have another networking break. And then we come back with our final fireside chats. For the students in the audience, hit Ryan Jenkins' fireside chat before his keynote. This is in the Wisconsin room. Going to be a lot of fun. It'll be good for you. This guy is really exceptional, and he is then also our final keynote, where we all come back together in the Overture Center to hear him. Again, really, really a lot of fun. And then after Ryan Jenkins, wait, you're going to laugh because I'm putting up some turkeys. Don't worry, not after Ryan Jenkins comes the turkeys. But after Ryan Jenkins comes our reception. With the career fair, we'll be on the perimeter of the reception. And then we have two virtual reality companies for some side entertainment. I've done Arch Virtual. It is hilarious. I had to do surgery. I don't know though if I did it very well when I was just trying to repair the leg, but it really is a lot of fun. All right, so let's see if I can just tell this story without actually reading it and just going off script. I kind of began with a story, and I'm going to end with a story. And I bet this is the first time you've ever seen turkeys on a train track to end a presentation, and it will probably be the last time you ever see turkeys on a train track in a presentation. But that's me. So I was inspired last week. I rode my bike to work, and when you're coming from McFarland on the Capitol Trail, you go underneath the Beltline before you hit John Nolan Drive. And usually when I'm biking, or a lot of times in life, I got my walls up, right? I have that, I've put it up. Sometimes other people put up those walls around me, but I'm kind of focused, whatever. But I'm not really taking in my environment. But when I'm riding my bike, I really kind of wake up. and I just enjoy life and take on all the senses. So I looked over to my right, and there was a tom turkey going down the train track. Okay, and he wasn't sprinting, right? He wasn't being chased. He was kind of that gait, right? He's going down there, and we all know he was determined, right? He was on a mission, because where was he going? He was going to go find that female turkey, right? She was down there somewhere. I missed her, but she was down there somewhere. So I bring that up because we do often live in these walls, again, that we've placed, others have placed. But as those women in country music told us, they broke down those walls, right? They took a risk, and they said, we can do this. We can do this. They were determined, right? So sometimes in life, we need to just stop and take in life, really watch what's going on, really listen, feel, touch, whatever. There's a lot we can learn, even from a dang turkey walking down a railroad track, right? I saw determination in that turkey, and I'm like, that's it. I'm telling that at the summit. It's about determination. So just like that turkey, he was saying to be determined to do more. Enjoy this program today and hear from these determined individuals. Every person that's speaking today is determined, right? They have taken risks. They're creative. They got out of their comfort zone, right? So that's something we can learn from all of them. So really listen today to all of them. So with that, enough of my turkey story. Had to end with a story, though. It is my privilege and honor to introduce both Beth Burnside of University of Wisconsin-Madison, School of Medicine and Public Health. She'll be followed by Karley Yoder of GE Healthcare, and then we're going to bring them out with Jay Hill of GE Healthcare Imaging, who's our board chair, COO, CTO, for some questions and answers. But with that, I now would like to introduce and please welcome our first keynote speaker, Beth Burnside.
Hello. I'm absolutely thrilled to be here to talk to you about the next frontier, deciphering biomedical big data to engineer new healthcare paradigms. In 2018, our chancellor at UW-Madison said, increasingly, universities have become the R&D centers of American industry. This is not a new idea. The University of Wisconsin has done this for decades, but this statement was a doubling down on this commitment. The University of Wisconsin-Madison and the School of Medicine and Public Health is committed to deep collaborations with industry to get our life-saving innovations to patients. The future of healthcare and biotechnology depends on it. In order for me to convey to you my view on the future of medicine and biotechnology, I'll use art as a vehicle. This is a picture of the Brown sisters. This image was taken by Nicholas Nixon, a photographic artist married to the second sister from the right in 1975. When he took this picture, he realized it was powerful, so he resolved to take a picture like this every year they got together for 40 years. This exhibit, the series of 40s, was viewed internationally by audiences, and critics that reviewed it called these images dizzyingly powerful. Why? Possibly because it shows that we all travel this human journey alone but have close connections, that we're all different but importantly find similarities and common ground. But for me, it really captures powerfully a scientific principle, the phenotype. So a phenotype are the observed properties of any organism, and they're made up of two components, the genotype and then environment. And as we see the Brown sisters, we realize they share so much genetic information, but they're very different. And time shows that environment makes a huge difference. So individuals have phenotypes, but so do diseases. This is an artistic rendering of a breast cancer. And we know that breast cancers have phenotypes. We've known this, again, for decades. So on the cell surface of a breast cancer, we have proteins and receptors. HER2 is an example. It sends an unrestricted growth signal to the engine of the cell. It's a bad prognostic sign, but it's a target for therapy. Estrogen receptors, progesterone receptors also make up the phenotype of a breast cancer. Fortunately, using technology, our in-depth understanding of phenotypes has gotten richer. In the 2010s, the Peru lab started to help us understand that gene expression was also an important part of a breast cancer phenotype and defined subtypes that really matter. For example, in pink and blue here, you can see that these different subtypes of breast cancer on the right have different survival profiles. So you can see the probability of death on the y-axis and survival on the x-axis. And you always want, if you're going to get breast cancer, you want to get one of those blue breast cancers because there's uniformly good survival. The pink ones are much more difficult to treat. So as I've stated, a phenotype is determined by genetics and environment. So science is bringing us some really great tools that we can think of as intermediate phenotypes. And I'm a radiologist, so you might guess those intermediate phenotypes start, in my view, with imaging. Imaging studies can help us see the interplay between genetics and environment. So on top, I'm showing a breast MRI, where we see background parenchymal enhancement, a risk factor that shows that interplay between genetics and environment, and on the bottom, an image, a mammogram, which shows breast density. Now, breast density is an incredibly important risk factor. Here we see 3 women, and you can see how different their mammograms look. On the lower left, we can see there's low breast density. As we move to the right, we can see very high white in the background. That's high breast density and a powerful risk factor and intermediate phenotype. Breast cancers on imaging also have a phenotype. This is a cancer on a screening mammogram. We see unique margins, distinct density, and shape. These have prognostic information. So it used to be that breast cancer risk could be captured with a small number of variables, maybe around 7. And physicians in the clinic could really deal with this. That was no problem. Now, when we look at germline genetics, we're discovering new variants every day. I put 150 here that have been shown to be associated with breast cancer, but really the latest literature is showing it's more like 300. Similarly, with breast cancers, we used to have about 3 variables that would define the phenotype. Now, we've got over 70. So this boggles the mind, right? Particularly if you're a physician. Now, I'd like you to think of a woman you care about, a woman who you want to get the best care if anything goes wrong. We'll call this your Wonder Woman. So breast cancer is a common disease. 1 in 8 women will get it, and over 40,000 will die in the United States. This statistic really hasn't changed much over the last several decades. In a decade's experience, we have so much data to learn from. Over 450 million women will get a screening mammogram, and over 200 million will be eligible but won't get that screening mammogram and will have those risk factors we now can look at. And just under 3 million women will be treated for breast cancer over a decade. So we at the University of Wisconsin want to learn from every one of those experiences. So we've put together a database of over 40,000 women with 120,000 mammograms, 10,000 ultrasounds, and over 3,000 breast MRIs. Undoubtedly, that Wonder Woman that you're thinking about is represented in this cohort, similar women to her. So what can we do? If we need to predict out of 8 women, there is 1 that will get breast cancer, this is what we conventionally have done. We've put a physician's brain to this task. And I'll tell you, when I'm in clinic, I'm very proud of my brain, but it is not up to the task on its own. So what I've dedicated my career to do is to develop artificial intelligence algorithms and techniques in order to manage this overwhelming amount of data. This is a Bayesian network that I developed with some computer scientists and informaticians at the University of Wisconsin more than 10 years ago. And we've also done innovative things like exploit the hierarchical nature of data. For example, when radiologists read a mammogram, we encode it in standard terms that observe a hierarchy. And genetics also has hierarchical and relationship information, like linkage disequilibrium found in this HAP map database. So when we look at how these algorithms perform, we often look at it with an ROC curve. And many of you are probably familiar with an ROC curve. What it measures is how many accurate diagnoses we can achieve on the y-axis and how many false alarms we want to avoid on the x-axis. So clearly we want to push that curve up to the lower left, and the perfect test is in that corner at the upper left. So what have we been able to do? What's been possible with these algorithms? Well, we found that compared to the radiologist, which is that sharp, straight-edged line, our algorithms can increase the area under the ROC curve to a statistically significant degree. We've also found that at the operating point, this point in blue, of a physician in clinic, we can improve both the sensitivity, the accurate diagnoses, as well as the specificity, or decreasing those false alarms. But what does this mean? What does an ROC curve mean to patients? What does it mean to that Wonder Woman you're thinking about? Well, in 90,000 women that we trained this algorithm on, it would have resulted in almost 40 accurate and earlier diagnoses and over 4,000 decreased false alarms. That's important. So now, I want to be a little less gender specific. I want you to think of your hero, really anyone you want to be taken care of when something happens in our healthcare systems. So Perry Pickard, another physician at UW-Madison at School of Medicine Public Health, has collected almost 10,000 CT colonographies over more than a decade. And undoubtedly, that hero you're thinking about is represented by similar individuals in this data set. So what has Perry been able to figure out? He's been able to model cardiovascular risk based on these CTs that are designed to detect colon cancer early. What has he found? He's found that the conventional way to measure cardiovascular risk, the Framingham risk score, does okay. This is another way to look at risk prediction. We divide individuals into quartiles and see how well those quartiles predict events over time. We can see that the blue, the top quartile, the risk prediction is pretty good, but 75% of these individuals, the lower three, are kind of overlapping. There's lots of work we can do. So Dr. Pickard figured out that if he measured the aortic calcium score, he could actually stratify risk better. So look at how those curves are now separated, so we can help people plan about their treatments and prevention, even if they're in the lower three quartiles. Comparing that to the Framingham risk, we definitely are making strides. Robert Uri and Glenn Liu are also scientists and physicians at the UW School of Medicine and Public Health and have collected over 1,000 functional imaging studies. Undoubtedly, that hero that you're thinking about is represented by similar individuals in this data set if they're unfortunate enough to get cancer. Dr. Liu and Dr. Uri they're diving deep into precision medicine, which is making sure we all know that not all patients respond equally to a given treatment. So we know that, but there's more. Even if an individual has a disease, not all disease sites respond the same. And this is more data that it's very difficult for a physician to respond to. So here is a schematic of patients with prostate cancer, and it shows how heterogeneous diseases are. So here we see in these series of prostate cancers that many of the cancers respond differently, even within a given patient. So this heterogeneity is important. So Dr. Uri and Liu have developed a software platform that assesses this heterogeneity. And here's where the partnership between academia and industry is so important. This technology has been licensed by AIQ, and it enables physicians to do longitudinal treatment response, reflection, to understand spatial location and quantification of disease burden. It's just something that physicians can't do in their head. So how do physicians use this? Well, the software platform captures quantitative comprehensive spatial understanding of disease burden at baseline, quickly identifies resistant disease, and then we can stratify treatment in a way that's much smarter than just guessing. So you can see the Uri group is all smiles here with the collaboration with AIQ, and we're really happy when this happens because we're getting our technologies out to patients. Another powerful partner with UW-Madison is HealthMine, so founded by Rock Mackey, who you'll hear much more about. UW has been a beta partner with HealthMine for over 4 years. So one of the great things about this collaboration is that it's deep. We really have worked closely with HealthMine in order to provide feedback to tackle the most important clinical questions and areas for decision making. Again, things that the human brain just can't do alone. So HealthMine is specializing in neurologic imaging, doing volumetric segmentation, and really trying to understand the impact of predictive biomarkers in really tough diseases like glioblastoma multiforme. They also are working in thoracic imaging, doing volumetric segmentation, hard for physicians to do visually, looking at change over time, which is crucially important, and also continuing to understand the impact of predictive biomarkers in lung cancer, another very important disease. So hopefully using art as a vehicle, I've helped you to understand the importance of a phenotype and helped you understand that it's deep as we innovate in biomedicine, but it will lead us to the ability to treat precisely, predict risk, and make important advances for people like this. This is a Wonder Woman who was treated for breast cancer when she was very young. I'm proud to say breast cancer really is on the cutting edge of this revolution in precision medicine, and I'm thrilled to show you her 4 years later with her beautiful family. They are certainly finding joy, aren't they? So, for all of our Wonder Women and all of our heroes, I thank you for your partnership, and we hope that UW can continue to collaborate with industry to move these things forward. So now I will hand the baton to Karley so she can tell you how to get these technologies over the last mile.
First of all, I want to thank the BioForward team for putting on this incredible event and inviting me to be a part of it. Second, I want to thank Dr. Burnside for those brilliant insights, but maybe next time we tag team Keynote, don't set the bar so high. For all of you guys, there's 3 things I really want to cover today, and I look forward to diving deeper on some of these topics in breaks and networking sessions. So number 1, to achieve that precision health vision that Dr. Burnside just talked about, we really need artificial intelligence. Number 2, artificial intelligence really needs a platform and an ecosystem. And then number 3, I want to share some of the learnings we've had at GE Healthcare as we've engaged on this artificial intelligence journey. Before I dive in to these chapters, though, I want to tell you a little bit about why I'm so excited about the job I get to wake up and do every single day. So we know these stats, but there's 7.7 billion humans on this planet. That's nearly 8 billion people, almost all of them who would desire better access to healthcare, better healthcare outcomes. If we look at just the little humans, there's 130 million babies born every year and 350,000 babies born every day. So just think about that. At the same time tomorrow, how many babies have been born in a 24-hour period? If we drill a little bit deeper into one country, India as an example, second most populous country today, but at a 1% growth rate annually, it is looking to be the most populated country, surpassing China, by 2025. That means that there will be around 75,000 babies born just in India on a daily basis. Now I'm going to ask you guys to make this a little bit more personal. Imagine an expectant mother in your life, either now or that you've known before, maybe a spouse, maybe a sister, maybe a close friend. Imagine that the journey to pregnancy has been challenging, maybe a little bit long, but at this point she's getting close to 20 weeks of her pregnancy, so about halfway through. She's getting a little bit nervous because coming up is a 20-week ultrasound where her doctor will be able to give her a little bit of insight into the health of her baby. The appointment's tomorrow, and she's feeling a little bit anxious. Unfortunately for her and for many folks all around the world, there is some accuracy to that anxiety. Ultrasound is a highly user-dependent task, highly user-dependent on the skill set able to navigate a small probe in ultrasound. And imagine just to do, for example, a fetal brain exam or a fetal central nervous system exam, there are 41 prescribed steps and keystrokes in order to collect the proper information. And layer on top of those 41 steps the fact that every patient's a little bit different, the baby might be positioned differently, and at 20 weeks, the baby's starting to move. This is not a simple task for a doctor to complete. And unfortunately, there is a global shortage of folks, doctors, nurses, sonographers, who are trained adequately to perform this task. In rural areas, this task gets even harder to do in an accurate way. And 4% of the time, there are abnormalities in the central nervous system that often get missed in this type of exam because the clinician is so focused on getting the picture and not capturing what may be developing inaccurately within the baby. So what can we do to make sure a clinician can pinpoint those 4% of cases where help is absolutely needed in a critical amount of time? At GE Healthcare, we've developed an AI algorithm that we call SonoCNS that runs within our Volucin E10 ultrasound device to serve exactly this purpose. As you can see on the slide behind me, this algorithm, embedded directly within the device, automates planes and detection steps that a sonographer would have had to do on their own before, taking those 41 steps down to 8 steps, improving your throughput by 80%, but more importantly, increasing your accuracy by 80%, and allowing the clinician to focus on the task of seeing the health of the baby and not just the task of collecting information. And it's going to take many examples like this where we can drive better both patient and provider outcomes if we're going to drive towards that vision of precision health. So Dr. Burnside did a great job of laying out what is precision health, what is precision medicine. And we really see that this is absolutely where healthcare is going. There are these factors that we're all very aware around capacity and productivity and patient outcomes that are driving the need for this improvement in precision health if we're going to drive better outcomes in healthcare. But I like to pause here because in a talk about artificial intelligence, there's a lot of hype. There's a lot of misinformation out there about the technology, and what I like to remind folks, what I like to remind myself is, take the driverless car as an example. No one's excited about the driverless car because it has AI. They're excited about the driverless car because it will get them to their job faster. It will get them to their family more quickly. It will make the roads more safe. So everything we do when we think about artificial intelligence has to come back to not just what is this cool technology, but how do we harness this technology to drive the outcomes that matter in the healthcare landscape. At GE Healthcare, we define precision health pretty simply as how do you do the right thing at the right time for every patient on a global scale. We break that down a little bit further into precision diagnostics. So how do you collect the right information about every patient, personalized to that patient, by creating smart medical devices that run very efficiently, that work just for you, to precision therapeutics where you're delivering the right treatment to every patient, smart ways of doing research to develop drugs, intelligent ways of doing surgery that are specific to you and your situation, and then precision monitoring, where we're really looking to take the monitoring that exists in a sophisticated manner inside the hospital, outside those hospital walls. So how do we monitor not just the unwell, but the well to keep them healthy? Before we move to the next chapter, I want to step back from healthcare for a second to talk about where we've seen great technology sometimes go awry. We'll go back to the car situation. How many folks have seen people texting or maybe looking up directions on their phone while they're out on the roads? And I can see you guys, so raise your hands. Okay, that's a lot of hands. So we know that really great technology, if it's delivered in the wrong way, actually detracts from the outcomes that the technology is trying to provide. So think about the cars where many of us drive, where we can speak directly into the navigational system, where we can answer a text or pick up a phone just with our voices. We have to keep this concept in mind as we think about the artificial intelligence we're developing in healthcare. It's not good enough just to make brilliant technology. You must also think about how you infuse it back into the healthcare workflow in a way that benefits providers and then their patients. So for the second topic, hopefully I've convinced you guys that artificial intelligence is an important piece of completing that precision health journey. What I want to talk about now is how do we get to that outcome? Let me take a step back and start with this visual, which was put together by Keith Dreyer and Dr. Alan Bibb. These two gentlemen run the the ACR Data Science Initiative, which is driving a lot of the data science forefront and thinking in the radiology space. They put this graph together, and what it shows you is essentially the infinite space that artificial intelligence can address. On one axis, you see all the different human anatomies that could be attacked. From another axis, you see all the different medical imaging devices. And one tiny little square is a particular finding within an anatomy and within a medical imaging device area. So that Sonos CNS example that I started with, the ultrasound example, is one small square in this overall diagram. We are going to need partnerships across vendors, across academia, across startups in order to ever address filling out this matrix. But when we fill out this matrix, we can drive real transformation across healthcare. A few years ago, I probably would have gone more deeply into some of the technology trends that have made deep learning possible. I'm guessing many of you are familiar with this now. But with the advent of GPUs, so supercomputing power, and the explosion of healthcare data, a stat on that one, back in 2010, healthcare data doubled every 3.5 years. By 2020, it will double every 3 months. That's now to Christmas, right? So the data that we have and the power that we have to do something with that data have just primed us to use deep learning and AI in the field of healthcare. In a place that has so much hype, I'm really inspired and motivated by the quote from a pretty smart guy, the Google CEO, that says, AI is more important than fire. But as Smokey the Bear says, don't play with fire. And I think if we look outside of healthcare again to consumer technology and many governments, there's been a lot of fires started just in 2018 and 2019 with harnessing technology in the wrong way. This is not something you're supposed to be able to read, but if you want to look more deeply, Kate Crawford and the AI Now Institute has done some fabulous research on where technology's gone awry. And we've all can remember the examples from the media of the Twitter AI bot that interacted with folks on the internet and within 24 hours became racist. Or the technology firm that built an AI screener for their resumes and started screening out females. I don't know about you, but I'd never want to screen out Dr. Burnside. So we know that if AI is not thought about carefully, it can go awry. We can't afford for that to happen in healthcare. So one of the things we've done at GE Healthcare, and one of the things I'd encourage all of you to do in your own institutions and practices, is start with your values. What are the ethics that you want to uphold and maintain as you think about your own AI journey? For us, that starts with patient safety and privacy. It moves into being a trusted steward of data. And then it ends with how do we make AI reproducible, trusted, and not biased? But ethics and values alone aren't going to get us there. I love this quote from Dr. Atul Gawande, where he says, under conditions of complexity, not only are checklists a help, they're required for success. I had the privilege of listening to Dr. Gawande present at an AI conference about 1.5 years ago, and he kind of looked at the room and said, we're here talking about AI, but we can't even adhere to a checklist in a routine surgery, right? His point was, it's great to have big vision, but if you can't build out a checklist of how you make that vision or ethics a reality, you're going to fall short every time. Fortunately for us in the data science space, there's lots of folks who are thinking about this, thinking about the checklists you need to undertake as you build artificial intelligence. TJ Patel has one of my favorite lists. This is actually free. I encourage you guys all to go download it and look at it. And at GE Healthcare, we've thought about our own checklists and our own ethics and then built a platform to embody that, to ensure that everything we do in this space reflects those values and holds to those checklists. So over the last several years, we've created a platform called Edison, and very simply put, what Edison does is unlocks data. So it works across all of the data in a hospital system, unlocking the data silos that have been entrenched and exist today, and then unleashes intelligence. And what I mean by this is we have tools to not just build AI, but then package that AI and deliver it back into GE Healthcare products across the spectrum, from imaging to monitoring to the therapeutics work that we do, so that it helps doctors and providers do the work they're already doing, but faster and better. Where I'm going to spend a little bit of time in this chapter is kind of in that middle section where we're building the artificial intelligence, and I'm going to walk you through the checklist that we've created for ourselves that we adhere to. And I'll use an example of a recent FDA clearance we just received for a really exciting X-ray use case. So for a second, just to imagine that a family friend gets in a car accident, gets wheeled into the emergency room. One of the very first things that would happen is they would take a mobile chest X-ray of the chest region, looking for something called a pneumothorax or a collapsed lung. Now, the current practice is that that image would go and sit in a radiologist's queue for up to 8 hours. Many emergency rooms are faster, but sometimes 8 hours. And if the radiologist doesn't get to that image quickly, the patient may have critical conditions and we may lose a life. What we've done with this app is we've actually created that intelligence to see that pneumothorax right in the moment of taking a scan. We prioritize that scan in the reading room right to the top, and then the radiologist can intervene right away and save a life. So I'm going to walk you through the journey that we took to get to that application. So the first checklist item we have is volume. You guys have all heard this, right? Big data, more data creates better artificial intelligence. And while that's true, there are some caveats. So the data having a large volume alone isn't good enough. You have to have the concept of balanced data. What does that mean? That means if I went to go train a model with 10 pneumothorax findings and 1 million normals, I would have a really poor performing artificial intelligence model. You have to balance your data with negative and positive findings if you're going to drive the best performances. You can see on the table that the highest performing model in an experiment we ran was not the one necessarily with the highest volume, but it had a pretty high volume, but also balanced data. So volume, yes, it's important, but alone it's not sufficient. Why is it not sufficient? If I trained a model here in Madison on balanced data on a large test set, there's a very good chance that model wouldn't work back in California where I come from, much less overseas in India or in China. So the variety of data when you're training a deep learning model is extremely important. A quick example of this is we were training our pneumothorax model on US-based data. We took it to India, it wasn't working well. We were trying to figure out why, and we realized that in India, the field of view is further away. And so the exam was actually picking up the empty space between the arm and the chest cavity and flagging that as a pneumothorax or a collapsed lung. You have to have a diversity of data and a variety of data if you want your models to generalize to serve a global population as opposed to specialize to serve a specific population. So volume, variety, and then the last one is veracity. And what we mean here is just clinical ground truth or annotations that you add to the data itself. This is really where the concept of garbage in, garbage out comes to play. And the easiest way to describe the advancing of curation techniques is The lowest form of curation is what we call weak labeling. So imagine you're training a neural network to know a dog. If you're doing a weak labeling approach, you would just label dog, no dog, no dog. If you're moving down the table and you're doing a strong annotation approach or a pixel level approach, you would actually take time to circle that image and show exactly where the dog is in the picture. If you take the time to do this, your performance skyrockets, and even with more limited data in a healthcare setting, you can have extremely good performance. And so we work with clinicians all over the world to do this type of work. So we have our checklist: volume, variety, veracity. How do we ensure that it's followed for every single artificial intelligence algorithm we build at GE Healthcare? Well, we've built a platform to do that. We can't leave it up to an individual data scientist in their own lab to follow that checklist. We've built a platform. We refer to our platform as Edison AI, and you can see the three main steps that I'll talk to around ingesting data, curating data, and training data for how you build artificial intelligence. In the first step of ingesting data, we've actually built out a process for taking every single data element we bring into our system and tying it back to the contractual rights we have to use that data and the patient and institution consents. So think back to our early ethics. We're building that traceability and trust of where the data is coming to into our very system. We also then, in that first box, have the ability to ensure that it's data that represents a global population. In the next step around curation, it's about how you add that veracity to the data. This can be a very time-consuming and expensive step. So what we've done is we've built the tools to most efficiently and effectively curate that data, add the ground truth. We use AI-assisted annotation, and we work with providers all over the world so that we're having doctors double-check each other's work to ensure we have the best possible annotated data. In the third step around training, we actually partner very closely with Amazon and with their SageMaker technologies. Why do we do this? When you look at this train of ingesting data, curating data, and training data, 80 to 85 to 90% of the time is spent in the first two boxes. And they're the boxes that are highly healthcare specific. So that's where we spend our time as a healthcare company. And then we partner with folks who are brilliant in the data science space like Amazon to leverage their best tools. But just building excellent data science within GE Healthcare is not enough to fill that matrix. It is going to take an ecosystem of partners working together to fill out that infinite space of AI opportunity that I showed in an earlier slide. One of the verticals where we're seeing a lot of innovation are commercial startups. We've seen over 140 imaging-specific medical startups begin over the last decade with over, I think it's up to $600 million of VC backing. Not all of these will survive and thrive and provide the perfect answers to providers, but a lot of them will. And we need to be able to work very closely with them and harness that insight. The other epicenter of innovation are these academic centers, much like what Dr. Burnside was talking about. They have access to data, they have access to clinical expertise, and a lot of the game-changing AI is going to come from those places. And then what we do as industry is we've learned an expertise on that final mile. How do you take the AI intelligence, wherever it comes from, built at GE on our platform or built by partners in the startup and academic space, but then deliver it right into the GE healthcare products or the medical device products that people already trust and use. It's going to take an ecosystem. So finally, what have we learned? I'll start with another example outside of healthcare. Raise your hand, and we're getting towards the end, so I'm going to do some integration or some audience participation to make sure you guys haven't fallen asleep on me. Who here has heard of the app No Wait? Oh, there's a couple more hands than I even expected. That's awesome. Who here's heard of the app Yelp? Okay. So No Wait was this really impressive technology that had been developed in order to put your name on a waiting list for restaurants that didn't take reservations. It had very low adoption and almost no one using the platform until Yelp acquired them and integrated it into their app. So I start with this again because even if we follow checklists, even if we have ethics and we build the best technology, it won't be consumed and warmly welcomed and trusted by a provider community unless we integrate it into the workflows that they already use. We call this the last mile. So a few examples of ways we've done that in GE Healthcare. I already touched on this one to start, but Sonos CNS, which saves clinicians time and raises the quality of our ultrasound reads. AirX is a great application we've built in the MR space that takes a localizer scan of the brain, so an initial scan of the brain. The current process now is a human then looks at that scan, sets a plane manually, and then runs the final exam. We've taken that human step out and done that by artificial intelligence, putting more time back in the system and also increasing the quality of the reads that go to the radiologist. An example in more of a post-processing imaging space is bone VCAR. Here we've taken the extremely time-consuming process of segmenting the spine region, which can take over an hour, and we've made it a 5-second task driven by artificial intelligence. Imagine what doctors can do with an extra hour in their day. And a final example is True Fidelity, which we've done in our CT space, which actually brings AI all the way back into the reconstruction or image creation part of the healthcare value chain, where we actually produce higher quality images by improving the signal to noise ratio. And just to let yourself imagine what we can start to do across healthcare if we apply AI to data creation itself and put more quality data out there in the world for clinicians and AI to interact with together. So in conclusion, I hope you guys have learned a little bit about how to create high-performing, unbiased artificial intelligence. I hope you've learned a little bit about the importance of integrating it into the workflow. But most importantly, I hope that one of your takeaways is this is a partner game. This is an ecosystem game. And I was thrilled to be able to present with Dr. Burnside and really show that it's going to take partnerships like GE with Dr. Burnside and other academics in order to achieve that precision health vision where we can see AI-powered health helping patients and providers across the world. So thanks, folks.
All right, good morning, everybody. Thank you, Karley. Thank you, Beth. Awesome talk this morning, and kind of brings home a lot of the innovation that's happening in this space. This is a time, by the way, for you in the audience to ask your questions. So if you want to get your questions queued up, we can address those. But I wanted to start with one. So in the popular press, if you read it, you'd think that AI is some sort of magical machine and eventually leads to our overlord robot masters coming. but more specifically, Beth, there's been a lot of discussion in radiology circles about, will this replace radiologists? Will it augment it? What's your perspective on that debate?
It's a great question. It's been asked since I was a resident, right? So, I'm not worried. I think Karley's last slide, which showed the solutions in this space, which is a partnership between industry and academia. I think clinical care will be a partnership between clinicians and AI. I just don't think we'll get away from that anytime soon. One of the really important components of that, and I think that it's almost my primary question for Karley, is how do we enable clinicians and AI to interact? How do we ensure that there's sufficient interpretability of models so that we can help clinicians have trust in them? Mm-hmm. So I think that interplay, figuring out how we get artificial intelligence algorithms that actually aren't a black box, that we can understand and explain the sort of recommendations that are being made, that I think is the future, rather than anyone taking over.
Yeah. No, I completely agree. There's a popular phrase that I think Kurt Langlotz maybe first said a couple of years ago that says, AI is not going to replace doctors, but doctors who use AI may replace those who don't, right? It's just like any other technology trend. When we saw the rise of digital tools, right? It didn't replace doctors, but it did help them do their jobs better. So I completely agree. And I think to your question about how a clinical community can embrace AI, I think I've met with a lot of startups who have built really cool data science that doesn't help your day at all, right? So I think the clinical community needs to be highly involved in the ideation phase of picking what use cases to pursue, and then also in the clinical annotation phase of putting your brain into the artificial intelligence. And then finally, we're still in early days of this technology. So partnering on introducing this AI into the wild, into clinical, and really, really validating it, pressure testing it before we roll it out in a more global setting, because you only get one first impression. And the moment we lose trust on this technology, we really lose, I think, our velocity to do a lot of good on a global scale.
Yeah, some of the first forays into this in this area kind of fell flat because trust was lost. What do you think are the other some of the other barriers to getting this into actually changing clinical practice? You know, what do you think we have to make sure that either as algorithm developers or as clinicians that we do to prepare so that we actually do change the course of treatment and for the better?
I think early collaboration is key.
Yeah.
If clinicians, I think, feel like they have an impact on the technology at every step along the way, have input, one will be asking the right questions, the important clinical questions, but we'll also be building trust. So I think there's a lot to like about constructing learning health systems where we're all invested in continually testing technologies. I think what's going to happen is, Karley alluded to it, is generalizability can be very challenging. And so every new, probably academic institution that adopts a new algorithm will probably have to make sure it works in a predictable way in their system. So I think involving clinicians and involving healthcare providers and health systems in general with the building and the vetting and the evaluation of these algorithms will go a long way.
Okay.
Yeah. You stole the best answer, but I'll add a little bit more. I mean, I think when you talk just about challenges, I think number one, the biggest challenge is just making sure it's grounded in what's clinically valuable. But I also, I talk about the first mile and the last mile sometimes when it comes to the challenges of building artificial intelligence. The first mile being, how do you get the right data and get it curated? And this is a long journey. How do we shorten that journey through partnerships to go faster to these valuable products? And then the last mile is how you deliver it. And I think about Google Maps, right? I'm from the Bay Area, so all my examples are around driverless car. But, you know, think about, I had to use Google Maps to get here today. You better believe that if my traffic route, they said, oh, can you please go look at another app to see how long it's going to take? And then can you go look at a third app to see which roads to take? And can you go look at, I would never use it. I'd be the only person using Apple Maps. Just kidding. So I think in healthcare, we need to think about that really carefully about how do we deliver all of this intelligence in a way that doesn't make your hard job harder, but easier. And so I think that first mile and last mile are really the key challenges, and they're only going to be solved, again, through partnership.
Before we go to the audience, just in between that first mile and the last mile, right, there's also at least one, if not many, regulators right, in this space. Right? And so I'm curious to what your experiences are in clearances for safe and effective products in the area where they're informed by AI. So maybe Karley.
Sure. I mean, I'm fortunate to work at a company where people have deep decades experience in regulatory, but I will also say I was with the FDA about a month ago, and they're trying to figure out how to regulate this space too. The pace of applications that are going to come across their desk are going to increase exponentially with this technology. And so I think it all comes down to the claims that you're making with the technology, and I really think we're going to start with a wave of artificial intelligence very focused on efficiency and productivity, because those are the claims that are more quantifiable with the metrics we have today. But I am encouraged that the FDA is looking to understand this technology intimately and engaging with folks like the ACR and industry to evolve kind of the way they think about this. But it is a hurdle from a technology standpoint for some of the things we could do from a science point of view.
Do we have any questions in the audience? It's really hard for us to see with the light, so I don't know if there's anybody out there with a question. Mike, is there someone there? Excellent.
Hi, Wally Block from UW-Madison and Clairvoyant. And thanks for these excellent presentations. My question is for Karley. On the Edison platform, you gave a lot of examples in radiology. Is GE planning to extend this to anesthesia and lunar and its other clinical monitoring products?
We definitely are. We've actually already started in specifically the anesthesia space, so more of a waveform use case. We started with radiology because that's where we have so much domain knowledge and intimacy with customers to really know that space. But we've already started rolling out work in the waveform and anesthesia space. And the vision we have for precision health requires multimodality, multi-data type use cases to be developed, because what really will start moving the needle in healthcare is not just making MR more intelligent or X-ray more intelligent, but the whole patient package around a patient, which includes imaging and pathology and labs and EMR, and bringing that together. It's not a 12-month journey, but it's definitely one we've already started pursuing.
Do we have another question?
Oh, the lights came on.
Much better.
Hey, thanks a lot. Couple questions. In terms of implementation, the technology and how it integrates into EMRs, could you address that? And how does that relate to reimbursement? And the second, as a woman in the room, I'm wondering and very curious about how many women are represented in the AI fields in general, and what might companies be doing about that?
EMR.
So I can start maybe on the first question about integration into the EHR. I will say it's so crucial. So Karley made this very wise statement that if a clinician needs to go to a separate box to check risk prediction algorithm, they just won't do it. We can't. We just don't have the time in clinic at this stage of healthcare. So integration into the EHR is really crucial, and I think there are a lot of technologies that are being utilized to enable that. And I think there's some, a lot of the oversight and federal regulatory progress is being made on mandating that EHR companies be more standardized so that applications can be integrated with the EHR. But I just wanted to make sure to reinforce your great question that it is absolutely crucial that that happens.
And reimbursement?
What was that?
Reimbursement?
Oh, yeah, I mean, that's what ends up driving a lot of healthcare decision making. Right. And so I think in actually what I've seen in the EMR and EHR space is a lot of the artificial intelligence is focused on the reimbursement side and catching quality issues that maybe would have gone uncaught earlier. EHR isn't necessarily a medical device in the same way some of the examples we talked about. So there's a little bit different in terms of the levels of claims that are being made. But I agree with Dr. Burnside. It's a pivotal piece, if not the most all-encompassing piece of a patient journey. And I know there's a lot of great work going on there. About the question for women in data science, I don't have the numbers on my fingertips at GE, but I'm fortunate to be a part of a team that has many women in our data science group. But I do think, like most technology sectors, we are seeing underrepresentation. So for all the students in there who maybe haven't declared majors, go do computer science. But it is an important issue that I do think is now starting to be talked about, and it's part of why when we talk about that variety, it's not just the data we use, but also the people doing the building. We've seen this play out in technology outside of AI, where if you don't have gender representation on who's building technology, you build products that are skewed in one direction. And so I think it's a huge issue and one I'm personally really passionate about.
There have been some well-publicized examples of algorithm fails that were in part due to that bias in the creators.
Yeah, the example I gave in my talk was just the tech company that will go unnamed, but out in the Bay Area, where they had built an AI screen for resumes and they were screening out women. That's such an obvious thing to think about, but it just if you don't have a balanced team, you're going to make those kind of mistakes.
I think also industry can really have a lot of power in advancing inclusivity. Some of the BioForward pipeline projects that Lisa talked about initially, where we tackle this in elementary school, tackle this in middle school. I think thinking about gender inclusivity as well as underrepresented race and ethnicity, it's all really important, and the AI revolution will only be successful if we're completely inclusive. So I think you all in the audience can have a huge impact with early pipeline programs.
That's great, thanks. Maybe this side, was there one over here? Oh, right in the middle.
I think AI, it's Eddie Wen from Covance. I think AI is such a big term, such as big data. AI means many, many things. Artificial intelligence, that's in comparison to natural intelligence, that's human intelligence. Now, artificial means computer. Now, computer means several different things. The number one is machine learning. That is, you have a big set of data, well labeled, plus and minus, positive and negative. Then you do ROC curve to have a high specificity and high sensitivity and low specificity. And then you have a very accurate diagnosis from there. Then you generate insight. Now you have algorithm based on very big data set, then you will generate insight, and that's the outcome. And the next step is, as Dr. Burnside said, you use that insight to treat patients, to do research, to improve the efficiency, to improve the 3 outcomes of healthcare, such as access, quality, and lower the price. But the thing is, now we have the insight. Now, how do we use that insight to direct our clinicians and researchers to improve the outcome in a most efficient way? And we want the AI to help clinicians and researchers to identify the scenarios, the conditions, the if statement in a computer program. You know, what if this happens? Then I do what? So that's the key. I wanted to talk more about how do you drive the last mile to deliver patient outcome, to deliver better research outcome, because AI means top down. You have insight now, you have a policy, you have a standard operating procedure, you have a SOP. Now how do I automatically identify those if statements, those scenarios, and deliver the outcome?
Yeah, go for it, and then I'll add on.
Yeah, I think it's a great set of issues that you've brought up. To me, your question asks a little bit about the psychology of the physician and the psychology of the patient. So artificial intelligence can spit out a number, it can represent a risk, but what's the threshold? What's the confidence? What's the preferences of either the health system or the physician? So within that very important psychology, we need to do much work to understand how artificial intelligence outputs are going to impact care. Those questions I don't think have been answered, and I think some of the algorithms that have come out before that have bombed has been because we haven't thought hard about those really important issues. I think it's even more important to think about patients and how we educate them to understand how artificial intelligence fits into those preferences and psychology. So to me, it's a lot about education. It's a lot about educating physicians in a different way and educating patients in a different way. It's a great question. You brought up a huge and important issue.
Yeah, I know I'm in the homeland of EMR, so I'll choose my words carefully here. But my husband's a primary care physician, works at a big health system out in California. So I hear some of his complaints about EMR. And what I think we did with the advent of EMR was we took a not ideal paper system and made a not ideal digital system. And I think when we think about how artificial intelligence can be applied, we have to be a little bit open to some of the processes changing. So there's a lot of things we don't take the time to quantify in healthcare because it's not worth the time trade-off. But that's not going to be true in an artificial intelligence world. So I think it's a combination of kind of moving up the chain as you described, but also kind of reimagining what this technology allows us to do that wasn't possible before.
Question here?
Hey, very nice talk. Stephen from AIQ Solutions. I have a question for Karley. So speaking of the generalization, generalizability of AI, so you need the data, right?
Yep.
But nobody wants to share the data. So what is GE's strategy going out there to convince people to share the right data to build a robust AI network?
No, it's a great question. We're fortunate that we create more data than anyone else in the world, so we have a little bit of a jump start. But when we go out and work with partners, we really try to find like-minded partners who also want to make a dent in the healthcare space and who are motivated by better patient outcomes, better provider experiences, and working very collaboratively on this type of research. We have announced academic partnerships in the US and globally. And for me, you hit on a very key point though. Data is not overflowing in the healthcare space. And so we spend a lot of time establishing and investing in those key relationships with clinical sites in order to build the data, but not just the data, the clinical expertise to build AI that's going to matter at a global scale. It's a great question though.
You know, along those lines, so Beth, maybe this is for you, but so we see, you talked about heterogeneity in data sets and how important that is, right, to get the right answer. And we do see collaborators like yourself and UW looking for those data partners who can help provide that heterogeneity. Do you think does that help with this problem that's brought up?
Yeah, I think Karley answered that so articulately. The key really is the partnership. We might sound like a broken record, but I think the biggest mistake industry can make, I think, is to just want data. Because Karley talked about it in, the data needs to be balanced, the data needs to be representative, it needs to be annotated, it needs to be accurate, and then it needs to be linked to the outcome that matters. Right. And so I think the biggest, one of the biggest challenges in this space is industrial partners who really only want the data. I think that will create algorithms that aren't going to serve our patients.
I think we have one more question.
So Marie Lotto, I work at Hologic, which is a women's health company. We have breast health diagnostic, but I work in surgical. So one of my questions is for Karley. In terms of AI and opportunities in the therapeutic space for medical devices, conceptually, what do you think of when you think of opportunities when you're more on the treatment side or the surgical side?
Yeah, I mean, I think those opportunities are limitless, but I think right now we don't have enough around surgical intervention. I think is one of the areas I think about most often, where we kind of apply broad brushstrokes in terms of how we approach a surgical intervention, as opposed to having that being perfectly adapted to each individual patient. And I think the more we can use AI to tie what's in an image, but not just the image, the biopsy, the patient record, to outcomes that we see happening on a global scale, and then what procedure steps were followed to get to the good outcomes, it'll start driving better treatment paths. And so when I really think about how that therapeutic space can be improved, it's doing some of these big image collection to outcome AI projects, so that for every patient, we're really confident that the treatment path that's being recommended is the one that's best for you as an individual. But I'd love to pick your brain on it at our break. But it's a great question.
And we've seen some more current developments, right, in, say, pre-surgical planning,
Sure.
And the ability to, liver embolization, for example, and the ability to go in and choose the vasculature appropriately. Treatment response in therapies. There was a whole session at ISSR recently about theranostics and treatment response, and how do you get more intelligence in understanding that response so you can see sooner. Does that ring true to you?
Absolutely.
Yeah. Look, thank you both very much. Excellent discussion. I really appreciate you both making the time to come here and talk to the group. Thank you all for your attention today and for your questions, and I hope you enjoy the rest of the summit. Thank you.
Thanks, folks.